Hi folks, in this video I am going to go over the first scenario of our Git lesson here. So in this scenario, Dev A is using Git on his or her local computer to kind of track the versions of the project code, and it's going to be equivalent to manually creating folders and saving off a specific version snapshot of the code. But in this case, we're going to use Git as a tool to kind of help us with doing that more autonomously. Okay, so if we head on over to this window here, we're going to start showing you how to use Git. And to orient ourselves, we're going to imagine the right-hand side is the developer A's computer or hard drive, and then we're going to do everything within Visual Studio code on the left-hand side. So before we start, a good extension to have installed on VS Code is this Git Graph extension. It's going to help us visualize what's happening as we use Git on. It'll help us visualize what Git is doing and how Git is tracking our code. So that's a good extension to install, and I'll reference it as we do certain things in Git so that you can have a visual feedback as to what's happening. Okay, so the first thing we're going to do is initialize the repository, and normally you would create a folder. We'll call this project Git demo. We're going to have this folder created in developer A's computer, and you'll notice it's just an empty folder. We are going to use VS Code's Git kind of menu here, and we're going to open. Actually, first off, we're going to open the folder. So let's do that. Go to where developer A has created an empty folder. And that's where it is. So we'll open that up, and it's empty. And then we'll use VS Code to initialize it. And once we initialize it, you'll notice that a .git folder will be created. So this folder contains everything about this Git repository. So if we ever wanted to get rid of using Git and just go back to our regular just having code or whatever we have in this Git demo folder, we can delete this, and it's like, there's no more Git. You've essentially gone back to square one. Git doesn't do anything kind of fancy where it saves off stuff somewhere. So with that said, if you ever delete the .git folder and you don't have it backed up somewhere, you've lost everything, unless you use the operating system's trash can and recover it. Okay, so let's initialize it. This file is a Mac file. It's normally hidden, but it's something that Mac OS creates. Windows might not have it. I probably don't have it. Might have something equivalent, but you normally don't see it. But Git sees it. We'll just ignore it for now. And then one thing to note is that in this .git folder, there's this config file, and we'll come back to this later. But in this config is how Git is all the settings in Git related to this Git repository. So we'll ignore that for now. And then we'll come back to it later as we do more. Okay. And then the next thing is to show that Git graph, there's nothing in here because we haven't started. It's a blank Git repository. So nothing is shown here, and that's completely normal until we start using Git. So now let's start using Git. So let's create a file. So we'll use VS Code to create a new file. We'll just call this file 1 for now. And here it shows up in our developer A file system. Okay, so we go to our Git tab. We can see our newly created file here. So U means untracked, so it has not been tracked by Git yet. So because it's a new file, so we're gonna save it or commit it to Git, and then Git will start tracking it for us. So first, there's two steps to kind of saving it. In Git, it's called committing. So first, you gotta stage it. So here we see the stage file, and then that's kind of like getting everything ready. So then Git commits it. Git is then ready to commit it, and later on I'll show you an example why staging makes sense. But for now, it might be confusing why it needs to be a two-step process. Okay, so we're gonna commit it, and here's where we type in our commit message. And it's gonna fail the first time because we didn't finish configuring Git yet. But we'll just go through it here. So a good commit message would be something that says why this commit, what's the purpose of this commit, instead of saying, so it's like, what is this commit, why is this commit important, rather than what this commit is doing, because Git will tell you what it's doing, what files are changing. So you don't need to kind of reiterate that. So instead of saying adding file 1, which is kind of what's changing, we're going to say something more like, why is adding file 1 important? So we're going to say, it's kind of hard because it's not a real project, but normally it would be like adding a new feature or adding something to your application. So right now, maybe a decently okay commit message would be demonstrate committing a new file. Okay, so now we're going to commit it, but Git requires us to kind of configure name and email. And there is no way to do it within VS Code through its menus. So we actually need to go to the terminal. You can use, if you're comfortable with command line and other terminal apps, you can, but VS Code provides one, so we'll just use that one here. So here, when we configure it, it's actually going to change the Git configuration that we talked about at that location in the git.git folder. So we're going to say git config, so you can see everything. Git config user.name. We're going to say developer A. And when we do this, it's going to add that to the configuration file. So with that said, we can actually just go in here and edit this file and add in all the configurations we want. That's another way of doing it. Sometimes it's easier to avoid typos if you use the command line. So the next thing we got to configure is email. So here we're going to say developer A at EE491F demo. Okay, and that'll be configured. So now, if we go back to trying to commit it, Git will be properly configured and we can commit. Okay, so the commit went through, and now we can see our first commit here. We added, and we can, you can't see the changes, but it's saying we added a new file. One other thing to note is we could, so this is configuring, this git config is configuring our repository here. If we wanted to, say you don't want to type that in for every repository, you can configure it for your entire system. So if we went to our user's home folder, there's this git config. Mine's is symlinked. So it's actually, yours would be in your home folder, but mine's is a little different here. So this is what mine's look like. And if we didn't want to do it for every repository, we can do Git Config Global and do a user.email developer A at EE491F.demo, and it would actually make the setting here. So this will affect every repository on this computer. And of course, again, if I didn't want this, I can just delete it, and it's the same as doing from the command line. Okay, so that's just an aside. We're not going to mess with that. So back to our repository, and we don't need this anymore. Okay, so we have our first commit. This is one snapshot in time. Let's add a line to this file. So we'll just say line 1, save that. You would have to do save, but I'm using shortcuts, so you might not see it. Okay. So let's go back to here. Let's close these ones. They showed up because I opened my home folder. So here, the M stands for is modified, and Git's telling you that line 1 has been added. So let's stage that. And we are gonna say demonstrate committing a new line. And now in our Git graph, we have 2 commits, right? This is the first one. And this is the second one. And here it's going to show us what changed, which is adding 1 line. So let's do one more. This time we're going to add a new file, file 2. And in this file, we're going to add line 1. Save that. And here we're going to add it all together. So we're going to demonstrate committing a new file with a new line, or a line. Might be more proper or accurate. Okay, so now if we go back to Git Graph, we have 3 different snapshots in time of our project. And if you, let's get rid of this since we don't need it. Oh, one thing about the terminal, I guess, when you're in Windows, you might have the option for PowerShell or Git Bash once you have everything properly configured. So this is how you can choose which kind of terminal you want VS Code open for you. Okay, all right, so we have 3 commits, and the thing to that help you uniquely identify each commit is these commit SHAs. They're hashes, and they help you uniquely identify each commit. So each version has basically an ID of this commit SHA, and that's how you can refer back. Okay, so now let's go back to older versions, right? This is what we wanted to do for our developer, right? Be able to go back and forth between versions of the application. So let's do that here. So right now, this circle indicates that's where our current file system is at. If we move, we should see file 1 and 2 change, disappearing, reappearing, and having lines 1 or not, right? So this master is the branch we're on, and I'll talk about branch a bit later, but that's the default name. Git's like the kind of like main branch is called master branch, but they're slowly changing to calling it main as well. So if you see main or master, that's kind of like just the default branch that most projects use. And it could be anything, but that's just conventional. So we roll back to this version, you should see file 2 disappear, because at this point in time, file 2 doesn't exist, and we should see no line 1 here because we only added that in the second commit, not this first one. So we go here, and the terminology that Git uses is checkout. So rolling back, changing versions, is called checking out. We're going to check out to this commit. Oops, sorry. I'm sure you want to check out. Okay, let's check out. So now we're on this point in time, line 1 is gone, and there's no more file 2. So we check out here, we should see line 1 here and still no file 2, right? So line 1 here, file 2 still missing. And if we check out to this last commit, we should see file 2 back and line 1. And we don't need to do it sequentially, we can jump around, right? We can go all the way back to the very first version where there's no file 2 and no line 1. And then we jump to the very last version, we will see both file 2 and line 1. So that is a great feature, right? That's essentially what we've been doing with by manually saving off code and timestamping it. So that pretty much covers how we would do it manually without Git, but Git offers additional features here that I'm gonna go over, and it's called branching. So this is kind of taking it a step further where our old manual way, it might be a little bit more cumbersome to do, but Git makes these next few features pretty easy to do. Okay, so branching is essentially a group of commits that's related together. So if you imagine if you're trying something new or you're building a new feature, you might not do everything at once, right? You could make one big commit, but it's nice to do things in steps, right? Like maybe get this portion working and make that a commit, and then get the next portion working and make that another commit. So these two separate commits, can be grouped together within a branch. And it's kind of an art form of what to commit and what not to commit. As you're starting out, I would err on the side of making smaller commits. That way you can have the benefit of jumping back and forth. If the commit is too big, when you jump, you might get something that's you don't have as much fine granular control. So err on the side of commit smaller and commit often. All right, so let's do that. We're gonna create a branch, and I think there's another menu here that does the same thing. So if we didn't want to check out, there's this also menu here, checkout to, but it is a little bit, takes some getting used to. But we're gonna create a branch now. So let's use it through the regular menu. So it's gonna create a branch at where you're currently at. So if we're currently on this commit on the master branch, that's where the new branch will be created from. So branch, create branch. And we're gonna give it a branch name. So this is another conventional thing. Normally we namespace it with feature and then the actual name of the feature. So we're gonna say add more lines, right? And some other namespaces that's common is fix, if it's a bug fix. Refactor is another one. We're just kind of cleaning up things. But this time we're gonna say we're gonna add a new feature, and it's because this is a fake project, we just say add more lines. Okay, so we're gonna give that our branch name, and here you see our new branch, and it's at the same location, same commit as master. So now let's create a new branch. One thing I forgot to mention was that branching is another way to try something. If we have a bunch of commits on this branch and we decide like, oh, this is not a route we want to go, we can just delete that branch, come back to master, and you can just start from this point in time again. So it's a great way to try something and then throw away the code if you end up finding out that it's not needed. Okay, so now we are going to go into file 1. I'm going to add line 2 here. So here it's indicating that this is a new line in this file. Oops, what happened? Oh, that's interesting. Okay, so we did a 2-line, file 1, let's do the same thing to file 2. Add in line 2. So both files have changed, both been modified, right? So let's go to our Git tab here. So you can see that it's telling us both files have been modified, and we can stage file 1, and stage file 2, and they're both staged, and we can commit it. We could do that. We also have the option of staging one file at a time. So here you can see the benefit of staging. Even though we made changes to both files, we can decide to commit just one change first and then commit the other change second. So you have this ability to selectively choose what you want to commit, and that's the benefit of this extra staging step. And I guess I didn't show it before, but you can stage and unstage to kind of choose which one you want to stage. Yeah, so we can actually commit file 2 first, the changes to file 2, but let's just do it sequentially. So file 1, we're gonna say updating file 1, commit that, and then in our graph you'll see the new commit. So now we're gonna stage file 2. Okay, so let's say updating file 2. And again, we look at the Git graph. We now have 2 extra commits on this feature branch, since this, in addition to this master, right, on top of this master. So now, we typically don't check out to commits because it's hard to know which commit to use. We normally just remember things by master. So master is usually the good version, and then features like, oh, that's the thing we're testing out. So if we wanted to kind of quickly jump back, we'll say check out branch, and if we look at our file 1, it doesn't have those new lines, right? Even file 2. I think we can split it this way too. Okay, so we check out back to our feature branch, those 2 lines should come back, right? So again, you can jump to a group of commits, to the last of the group of commits. So again, rolling back, switching between versions, very easy with Git, instead of manually trying to figure out what changed between the code in this folder versus the code in that folder. Okay, so at the end of your feature, after you try something and maybe decide that it works, or you're like, oh, this feature is done, we want to merge these changes back into master. So let's do that. So we have to go to the branch that we want to merge into. So we want feature branch to merge into master. And then we'll say merge branch. And this is the branch that we want to merge into, merge from. So we want this feature branch to merge into master. And here you see the updating file 1 and updating file 2 is now on master. And once you're done, you should really delete the branch because you no longer need it to kind of like clean things up. Because all the changes relating to this feature is in master, so you're good to go. Okay, so that is the most basic merging. I'm just going to this other merge feature called no fast forward. You notice that once we're done, we don't know that updating file 1 and updating file 2 were related and they were actually a separate branch. So this is just a personal preference. It's not required, and it really depends on your team how they want to implement merging and fast forwards. So I'm going to create a new branch and kind of go through the same thing a little bit more quicker this time, hopefully. So let's create a new branch. And we're going to say feature add, yeah, or maybe this time demonstrate no fast forward. Okay, so let's create this branch. We could have, because the branch has been deleted, we could create a new branch with the same name as the old one. But yeah, Git allows us to do that. So here, let's just add line 3, save that, line 3, save that. So let's again commit it. We'll say updating file 1, updating file 2. So here we have two commits on this new branch, and I'm going to merge it back in. And this time we use no fast forward. I think we're done with these here. So, okay. So we have to go to the branch we want the feature to be merged into, which is master. So here, the circle's on the master now. And now we want to merge we want this one, but last time yeah, I think going through here is not going to give us the fast forward option. So I'm going to use this menu here and merge into current branch. And here we have this fast forward option. Create a new commit, even if fast forward is possible. So this is essentially saying don't fast forward and create this extra commit. So we're going to merge it with no fast forward, and you notice it kept the shape of the feature branch. So now if we delete it, you'll know that these two commits were related in a branch before it was all merged. So I like seeing that. So I personally like the no fast forward option. And then the last thing I want to say about no fast forward is, let's do this one more time. Let's go back. Let's go create branch. Say demonstrate auto no fast forward. Okay, so let's do the same thing this time. Maybe this time we'll commit it in opposite orders. Line 4, save and quit that. Line 4. Okay, so both are ready. This time we'll do it in reverse order, just so it shows up maybe a little differently. Updating file 2 again. Updating file 1 again. Okay, so now we have our 2 branches. At this time, say you notice something, but it's not related to this feature. You know, like, oh, when you're working on this feature, you notice that this a bit of code is like kind of needs to be changed or updated. So you could check out to master branch. So now we're in master. And let's say file 1, you decide, oh, there should be a line 0 in file 1, right? So now we're going to add this change to master. Say fix file 1. Okay, let's commit this to master branch. So master has this one branch on one commit. Since after feature has been already branched off. So now let's merge. And this time, because this commit is here, it's going to force this branch looking visualization, because it cannot just apply these 2 pink commits directly on the blue master branch. You notice before when we branched off, there was no commit on master, so they can just, the 2 commits can be directly added to master branch. All right, so let's see, how do we do merge? So master, and we're gonna merge this feature branch in. So merge branch. Okay, so from this feature branch, we're gonna merge into our current branch master. And you notice that the shape is retained. So that's something about fast forward. It kind of just helps you visualize these groups of branches, or these groups of commits related to a specific branch, which is usually a specific feature. So you kind of have an idea that these 2 commits were related. So if you have a commit on master, it will always kind of create this branching visualization. But if you don't, then you need the no fast forward. Okay, so the next thing, so doing this type of scenario manually with these folders would be even harder. Okay, so then the next thing is, all right, let's clean this up to delete the branch. The next thing is we use tags. So tags is a way to label a commit. Branch is kind of like, you might have a branch that's like the main stable branch, but it always kind of updates, right? It changes. You notice that master has progressed through these commits, right? So master, the current state of master is always moving. But what if like this commit means something? It's like maybe it was a release and you want to capture that. So that's where tagging comes in. So if we were to kind of go back to this commit here, and it is special, so let's tag it. So we'll create a tag. Let's say version 1.0, and you can usually annotate the tag with a message. So let's say initial release of our product. So here we can view the details, and let's go back to master. Check out here, and let's tag this one. And we're going to say version 2. Let's say what would be initial release, and then maybe major refactor to use new framework. Okay, so some big change that we want to remember. So here you can see these are tags, and if we add a new commit, say maybe 92A update, right? We make some update, commit some like minor update. So, oh shoot, sorry, I made this without being on a branch because I was in a tag. Okay, so we'll check out the master. That update has been gone, but let's do it again. This time on master branch. Okay, sorry about that. Okay, some minor update. So master is moving on, but the tag is still there. Excuse me. So these tags allow us to kind of like know which commit is something important. Major releases usually. So again, you can check out tags. Branches usually group some commits, but usually we don't want lots of branches laying around, so we merge them into our main branch and then remove them afterwards. Okay, so the last thing that I want to share about using Git to kind of track your project is the Git ignore file. So Git's really cool. It just operates on files. So there's nothing special about this file. It's just another text file, but because it's named Git ignore, Git recognizes it and will use it as another configuration. So imagine if your project uses some secrets, right? Some password or something to log into some service that your application might need. You don't want that secrets file to be tracked, right? Then all your credentials is available for everyone. And when we publish the repository, we're not doing that now, but that's a thing we'll do later. But not just secrets, but maybe data, right? Your data can grow. So if you have like a big CSV file, it's usually not, you kind of want to separate data from source code. So any sort of data you don't want in your source code because it's going to bloat your repository. You just want to deal with code, right? If you want your code to work with many different data sources, right? Usually, or your data can be anything and your source code should run the same. So it's not something you want to be included on your source code. So that's something that you don't want to be tracked. And then if you're coming from C, if you have auto-generated files like shared objects or something that's generated from your code, but is because you have the code, you don't really need these things that are auto-generated. So those things usually you want to keep out of your repository as well, because that just adds bloat. And once you change your code, they change automatically. So you only need your code to be tracked, not these auto-generated artifacts. So you have one source of truth, right? Your code. So the last thing is maybe your code generates a lot of artifacts, maybe builds, right? If you want installers that install your application. So in it, maybe you have some installer.zip or exe or something, right? Installer exe or some sort of package.zip, right? Something that you generate, but you don't want, you can just generate it as you need it. You don't need it to be stored all the time. So Git's going to try to track all these things unless we tell it to ignore it. So that's where this file comes in. This git ignore. Yeah. And then we don't need these files here. Okay. No, we don't need that. We need this. So as we update this git ignore file, we're going to tell Git to not need to track these files, right? You can tell Git to ignore it. And Git's very good at oh, sorry, lost the train of thought there. Okay, so again, once we add it in, we're going to ignore this Mac OS file. If we save it, Git's going to say, oh, we don't need to worry about it. We're just going to ignore it. We can also do wildcards. So anything with that the SO extension, we're going to ignore. So anything with CSV, we'll ignore. Anything with secrets, no matter what the file extension is, we'll ignore. And there's really a lot of flexibility to these wildcards. It can handle globbing. So if there's subdirectories and stuff, you might use 2 asterisks. I'm not going to go into that, but it has the power to do that. So this last part is Git doesn't know about folders. It doesn't track folders. It just tracks files. So we could say artifacts folder. It will remove everything in that folder, and if we didn't commit any file in that folder, this folder wouldn't be tracked as well. But sometimes it's good to when you have a project, you want the folder directory to be set. You don't want to have to create extra folders because sometimes the code is expecting a folder to be there. So Git also has this thing where you can say, don't ignore a keep file. So this way, if we create a keep file, Git will create this folder for us. So in order for this to work, we need an asterisk saying, don't commit any file under the artifacts folder, but do track this .keep. And once it tracks .keep, it automatically keep this artifacts folder. It might not make sense now, but if you ever need a folder to be in Git, but not certain files, most of the files, then you can do something like this. And we could also have done like exe or something, but I'll leave that exercise for you to work out. So here, we're just going to commit this and say ignore non-source code files, but keep artifacts folder. I just like adding this slash to indicate it's a folder. It's a preference thing. Keep artifacts folder. So entire project structure is tracked in Git, or is version control by Git. Okay. So that more or less goes over everything I intended to say in this scenario. Hopefully now you have an understanding how Git, even used by a single developer, can save you a lot of manual work of figuring out what changed and what not. And hopefully that by itself is super useful to you. You can see the benefit. And then once we go on to describing the other use cases of Git, hopefully you see even more potential in the power of Git in working with software projects. Okay, thanks for watching.